Hi, I'm Dr. Emily Bates. I am a mother and I'm a biomedical scientist with a PhD from Harvard Medical School. I've taught cell and molecular biology, biochemistry, and pharmacology to people who are now doctors. This pandemic has been hard. People have suffered the loss of loved ones, the loss of income, the loss of their health, and normal human interaction. We all hate coronavirus. We want this pandemic to be over. But many people feel concerns about taking the new vaccines. It's normal to find the science surrounding a new vaccine confusing. I want to help. I will explain how the coronavirus invades our body and affects it. Then I'll explain how the vaccines work and address all the concerns that I've heard. First, I want you to take a moment to think about what would help you to feel comfortable or confident taking a vaccine. I also want you to know that I don't have any conflicts of interest. I don't have any stock in any biomedical company, and I also don't have family or friends who work for any of the companies that have developed these vaccines. I'm going to share my screen so that you can see my presentation. So some of the questions that I've heard are, is mRNA technology new? What are the side effects? Can the vaccine affect fertility? Should I take it if I'm pregnant? Can they track you with this vaccine? Can the vaccine modify my genes? This vaccine was developed fast. How do I know if it's safe? First, it helps to understand how the coronavirus works. The coronavirus is like an army invading our body. Its goal is to take over as many cells of our body as it can to become stronger. The immune system is our defensive army. Its goal is to detect and destroy the virus and infected cells that are working for the enemy. A virus is a coat or a uniform that houses virus genes, all the instructions to make virus. A virus can't make more of itself alone. A virus can only make more of itself when it infects a cell. It hijacks your body to produce more of itself. In your body, a virus can mutate to become stronger, more infectious, or deadlier. These are those new variants that you hear of. Those were made in someone who was infected who had no idea that they were making a new variant. That's why it's so important to prevent infection. Different viruses have different coats or uniforms. Here, the coronavirus is compared to a polio virus and an influenza virus. If your immune system hasn't seen a coat before, it has no defense against it. It doesn't know that it's dangerous yet. Here is a video animation that was generated by Dr. Janet Iwasa at the University of Utah. The animation is available here at this website that is in blue. And it's described in all the technical detail in that animation. I'm going to describe it in more general terms, but please go to her animation website and watch it there too. So these teal spikes are decorations on the outside of the virus, and they're in blue, they're in red in many of my other pictures. Inside of the virus contains the genome, or all the genes and instructions to generate a new virus. So here you can see that virus moving around as it would in the air. When we breathe it in, it can come in contact with our cells. Our cells are much bigger than a virus. So you can see here is the coronavirus coming in contact with one of our cells. Our cells also have decorations on them that have specific functions, but the coronavirus takes advantage of our cells and uses equipment on our own cells to get into our cells. So you can see here, those purple little things are called the ACE2 receptor. And then the yellow and orange also help the coronavirus get in. So now you'll see those spikes extend down into one of our cells and pull the virus close. Then the virus is going to dump all of its genes into one of our cells. And you can see that then those decorations that were on the outside of the coronavirus are now on the outside of one of our cells. This marks that cell as infected. Once the virus is in our cells, it takes over our cells' machinery to make more viruses. It no longer is working for you, it's working for the coronavirus army. It's switched sides. Infected cells release new virus to infect more cells, to take over whole organs. Coronavirus can shut down whole organs if it isn't stopped. In the lungs, that would mean that you couldn't clear fluid or breathe. That's called pneumonia. The coronavirus can also produce blood clots. It damages the heart, the liver, and the kidneys to cause failure of these organs that can kill you. It damages the brain by causing strokes and mini strokes. Even now, over 500,000 people have died of COVID-19 in the United States, and over 2 million have died throughout the world. These are all valuable people who were loved and lost. When we are infected, we produce coronavirus and we spread it with our breath. So what helps the coronavirus army take over our bodies? Having a coat or a uniform that isn't recognized helps it whenever it infects a new person. Then having a lot of virus come in at once really gives the coronavirus an advantage. For that reason, we wear masks to prevent so much virus coming in at the same time. The third thing that would really help the coronavirus overtake our body is having a weak immune system. That way, our body can't build up a defense in time to save our organs. What helps the immune system army? A warning sign of what the virus coat looks like, or having a smaller viral load come in at the same time. That's why we wear masks. That's why when we come in contact with someone who's infected, if we have a mask on, not as much virus will get in at once. So the coronavirus has the advantage until most of us are vaccinated. A vaccine is a warning sign to your immune system to kill the virus before it takes over your cells. The first vaccines were developed from dead or crippled virus so that your defensive army, your immune system, knows the enemy uniform. Later, vaccines were made of virus surface proteins. This is like only part of the uniform, like the hat. Then you're giving a sign to your immune system saying, anyone wearing this hat is dangerous. You need to destroy it before it destroys you. The hat itself is not dangerous, but it is a warning sign. These vaccines work. Here you can see a graph that shows many different viral infections, and the size of the circle shows how many infections there were in the United States in that year. So you can look at measles infections and polio infections. A lot of people were scared of polio crippling or killing their children before the vaccine was developed. The vaccine is denoted by this orange circle. And when it was developed, people took it and that eradicated or completely destroyed the polio virus in the United States. So now we don't have to worry about our children being crippled by that terrible disease. But it took a long time to develop these vaccines. Making vaccines from dead virus or surface proteins is slow and it's expensive to develop, to produce, and to adapt. Who wants to be in this pandemic for another 3 to 5 years? The other problem was that the virus or protein had to be grown in cells, and those were often chicken eggs. So if someone was allergic to chicken eggs, it would be hard to take those vaccines without getting an allergic reaction. So mRNA to the rescue. M stands for messenger, and RNA is degradable instructions. It's like a pattern that you would use to make a uniform. So our cells can produce part of the coat as a warning sign of what the virus looks like. mRNA vaccines could be developed fast. And so for the past 3 decades, scientists have been trying to develop mRNA vaccines. mRNA itself, even after it's been developed, can be produced really quickly. For example, in my lab, we can make mRNA in about an hour, whereas if we were making a surface protein, it would take about, well, several days anyway. mRNA can also be adapted fast. We can read the instructions for a new variant and then immediately start on developing a new vaccine just by reading those instructions. So there's less potential, and then there's also less potential for allergic reactions because it's generated just in a test tube with salt water and a few ingredients rather than in chicken eggs. So what is in an mRNA vaccine? There's a tiny lipid or fat droplet. Those fats have fancy names that you would read in the ingredients for a vaccine. That fat is special in that it will help the mRNA get into our cells, and also it protects the mRNA. The mRNA for a surface protein is also in the vaccine. That's the pattern to make part of that enemy uniform. Then there's salt water and sugar. Nothing scary. So our cells are going to make part of that spike protein to show our immune cells what the enemy is wearing. And this is how it works. So here's that little fat droplet touching one of our cells. It drops in some mRNA. That mRNA is read by our cells and produces part of a spike protein. The spike proteins are then able to warn our immune system of what the enemy looks like. Meanwhile, the mRNA is degraded. Within 2 hours, there will be no trace of that vaccine in your body, but the warning sign is given. So the warning sign of what these spike proteins look like is displayed on the outside of a cell. So it looks like it might be infected. mRNA is not DNA. It's chemically different. It cannot modify our genes. mRNA cannot go near our DNA, which is our genes. Our DNA is housed in the nucleus and packaged tightly to protect it against any kind of damage. Our body will then generate antibodies against those spike proteins. It is a warning sign, like something that would say, anyone wearing this hat is dangerous. Anyone wearing this spike protein is dangerous. Now, our immune response is absolutely amazing. It will produce antibodies to neutralize viruses. The antibodies cover the virus so that it cannot infect cells. It'll bounce right off. The virus cannot replicate if it can't get into our cells, and the virus cannot turn your cells against you. Secondly, antibodies present the virus to cells to teach other immune cells to destroy or eat that virus. I've made this type of cell into a Pac-Man because I'm a child of the 80s, and it's eating the virus. Then enzymes are also activated to break up anything that looks like the virus. So we're actually generating weapons to destroy coronavirus when we get vaccinated. Lastly, a vaccine teaches our immune system cells that are called the natural killer T cells to kill our own cells that are infected by the virus. This is important because we don't want any traitor cells to be making virus and working against us. So those cells need to be destroyed. Vaccines warn your immune system to keep the virus from infecting new cells, to detect a virus and send a warning signal, to destroy the virus itself. We make weapons to kill coronavirus when we are vaccinated. And fourth, they kill infected cells. Vaccines help us kill infected cells that are making more virus. So vaccines teach your immune system, so your immune system has a head start in the war. Your body makes weapons to destroy the virus, and by getting the vaccine, you decide that you will not work for the enemy, the virus. So how are vaccines different from medications like Tylenol or ibuprofen? Tylenol and ibuprofen distribute throughout our body when we take a pill, and it stays in our system for several hours. These medications will treat symptoms. They'll help you to feel better and lower your fever, but they won't destroy the cause. They won't destroy the virus itself, and the virus will continue to damage our cells and our organs. However, vaccines destroy the cause. They destroy the vaccine. The vaccine destroys the actual virus. The vaccine is also restricted to the injection site and then warns your immune system so that it can protect the rest of your body. The vaccine is broken down within 2 hours after injection. So let's talk about some of these concerns that I've heard. It was fast. It was fast that this vaccine was generated. So how do we know if we can trust it? There was animal testing done for the safety and to know if there were antibodies that were generated in mice and monkeys. And those results were published both in scientific journals and also in general journals. So here is one about the Pfizer animal tests, and here is one about the Moderna vaccine tests in monkeys. Then clinical trials ensure that a vaccine is safe and effective in humans. Phase 1 clinical trials are done in a small group of people, up to 500 people. And it looks to see if a vaccine is safe and produces antibodies. Phase 2 clinical trials look to see if a vaccine is safe and effective in a small group of people, up to 1,000 people. And phase 3 clinical trials are looking to see if the vaccine is safe and effective in a large group that includes a diverse set of people of different ages and racial backgrounds. And so this will be between 10,000 and 50,000 people. So how do you know if you can trust this clinical trials data? It was collected in over 100 hospitals and by several different medical professionals, doctors and nurses, who have no vested interest in the results of the clinical trial. Then it's reviewed by 5 different monitoring agencies: the Safety Monitoring Board, the independent scientists, career scientists at the Food and Drug Administration, an advisory committee on immunization practices, and finally, the Center for Disease Control. None of these panels of people have any vested interest or monetary gain from the results of the trial. So can you trust the data? Yes. No corners were cut, and there were no conflicts of interest or monetary gain by any of the reviewing committees. So let's go through the data together. For the Pfizer COVID-19 vaccine, there were 43,448 volunteers in the clinical trial that was conducted in people who are 16 years old and older. 45% of these were 56 years old through 85 years old, so in a risk group. In addition, 30% of these people were racially diverse and identified as either Hispanic or Black. The volunteers were divided into 2 separate groups. One group of people would just receive a shot that had no vaccine, but they wouldn't know whether they had the vaccine or a blink shot with nothing in it. And then half of them got the vaccine. Then those 2 groups of people are compared to see how many people get COVID-19 symptoms or any other potential side effects. In addition to this COVID-19 vaccine clinical trial, by February 5th, over 29 million people had received this vaccine in the United States and were given the opportunity to report any side effects. So let's compare the data from the clinical trials. Of those that got the placebo, that means they didn't get any vaccine, there were 162 cases of COVID-19 that were moderate or mild, and 9 severe COVID-19 cases. Now, when people had the vaccine, they were protected. And for this group, there were only 7 mild COVID-19 cases and 1 severe COVID-19 case. Now, remember that both of these groups had people that were at risk for severe COVID-19 and even death. But there were so many less in those people, so many less infections and symptoms in people that got the vaccine that we know that this vaccine is effective. It's 100% effective for 95% of people. For those 5% of people that it doesn't completely cover, it reduces the effects of COVID-19 to quite mild symptoms. Now, for the Moderna COVID-19 vaccine, it was conducted in people who are 18 years old and older. And there were 300 participants in both the phase 1 and phase 2 clinical trials, and then 30,000 participants in the phase 3 trial. There were, among that group of 30,000, there were 11,000 people of color, 5,000 people with diabetes, severe obesity, or cardiac disease, which are risk factors for severe COVID-19 symptoms, and 7,000 people over the age of 65, which is another risk factor. For those people who only got an empty shot, no vaccine at all, there were 196 cases of COVID-19. 30 cases were severe enough to require hospitalization, and 1 person died of a COVID-19 related death. However, if they were protected by the vaccine, there were only 11 mild COVID-19 cases. There were no severe cases. So again, 95% of people were completely protected from getting COVID-19 at all. And the 11 people who did get COVID-19 had a very mild case, even if they were in a high risk factor group. So the Pfizer and Moderna vaccines reduce COVID-19 symptoms to a cold, if you even get infected at all. But when you get the vaccine, you can always report any kind of side effects that you have. There's a national website to do that. At this point, 53,797 172 doses of Pfizer or Moderna COVID-19 vaccines have been administered in the United States as of February 16th. And worldwide, millions more people are being vaccinated against COVID-19, and this is great news for all of us. So you might think, well, this vaccine depends on our immune system working. That's true. So what about our friends that are immunocompromised, like pregnant women or older individuals, chemotherapy patients, or people who are on immunosuppressants? These vaccines were tested in some of these individuals, and it did prevent severe disease and death. But for these people, it's especially important to get the vaccine as soon as possible. Remember, it's harder for our immune system to mount a defense if our immune system is suppressed for any reason. The other thing is that we can help protect people who have weaker immune systems by getting vaccinated ourselves. That way, they don't even have to worry about coming in contact with the virus. Our strong immune systems make the weapons against the virus to cover for the weaker immune systems. So what are the side effects of these vaccines? It's very normal to get a sore arm when you get a vaccine. And the reason for that is that your immune system is sending cells to the site of where something new is introduced, and they're trying to learn about that invader. And so the immune system cells that rush there is called inflammation, and it might make you a little bit sore. But that's just a sign that the vaccine is working. But don't worry if you don't have a sore arm, that's okay too. On the second dose, it's also fairly common to experience fatigue. People have also reported feeling a headache or mild fever, and some even nausea. And all of these are normal symptoms of immune system activation. They tell us that our immune system is working, the vaccine is working. You can think of it kind of like the nausea that happens when you when someone is pregnant, it's not telling you that your body is damaged. It's just telling you that the pregnancy is working and it's normal. Okay, there are also rare events such as allergic reactions that can take place. In 5 people out of every million, allergic reactions have taken place. For this reason, when you get the vaccine, you're asked to stay so that a doctor can monitor you and make sure that one of those allergic reactions doesn't take place, and they can treat it if it does. Allergic reactions are treatable, and it still would be way better to be protected from a deadly virus, even if you do get an allergic response. So why does the second dose have a worse side effect? This is likely because the foreign object showed up again after we already started building an army against it. So your immune system sees this big threat coming in again, and it builds even bigger defensive army against that virus. So that helps us have a stronger immune response to prevent infection. So what about the other vaccines that we've heard about? The Johnson & Johnson and AstraZeneca vaccines give instructions for making part of the spike, but the method that it gets into our cells is different. It's also great that these other vaccines are being developed. The more vaccines that we have, the better. The sooner that we can all get protected, the better off we all are. The other advantage is that the Johnson & Johnson shot is only one injection, and it prevents severe COVID-19. I plan to get the first possible available vaccine for myself. How were these vaccines developed so fast? One thing is that funding was readily available. The whole world was throwing money at this problem because we all want to fight coronavirus. The other reasons are that we've been doing basic science research for decades. We can read genes fast now. We know the code for a surface protein. Basic science research about how RNA works and how it can be delivered to cells has been going on for decades. So new vaccine methods had already been developed and could be utilized for this specific pandemic. And the last very important thing is that scientists from all over the world were working together on this. We can do things faster if we work together. So is this mRNA technology new? No. Scientists have been working on developing mRNA vaccines since the 1990s. I've been working with mRNA since at least early 2000, maybe the late 1990s. And mRNA vaccines against cancer, the flu, HIV, Zika, and rabies started clinical trials before 2017 and are reported in this article below. But it takes longer to enroll people in those clinical trials when there's not a global pandemic threat going on. Less people want to enroll in a clinical trial. So can the COVID-19 vaccine affect my fertility? Absolutely not. People became pregnant during the clinical trials for all of these vaccines, even though they signed paperwork saying that they were trying to prevent pregnancy. The other reason that we know that they can't affect fertility is that the vaccine is just a tiny part of the uniform of coronavirus. A coronavirus infection itself doesn't impact fertility, so the vaccine can't either. Should I take the vaccine if I'm pregnant? Well, let's just think about it together. High fevers are harmful to developing babies. COVID-19 causes high and enduring fevers. Immune systems are suppressed during pregnancy, so the coronavirus can get further and cause more damage in someone who's pregnant than someone who isn't, who's the same age. So a vaccine is the best way to protect your baby from that high fever that's associated with a coronavirus infection. If you do happen to get a mild fever when you take a vaccine, you know that you took the vaccine right then. So you can watch for that mild fever and take Tylenol if you get that, if your temperature starts to rise. So this information I found in 3 very believable sources. One is the the American Journal of Obstetrics and Gynecology, and it was published on February 1st of this year. And then both Harvard Medical School and the University of Michigan's School of Medicine both published this recommendation on their websites. So this is the article that I told you about, and you're welcome to look it up. Another question that I've heard is that they might, are they tracking me with this vaccine? And the answer to that is no. We don't have tracking devices that are this small enough to fit through an injection needle at this point. But if you're concerned about being tracked, your iPhone, Facebook, social media, and the internet do track you. So if that's what you're concerned about, then you should get rid of those. So do I wear a mask after I get the vaccine? Yes, until most of us are vaccinated. So the end is in sight. One reason for doing this is that it helps everyone else to wear a mask if we wear a mask. We're racing against new variants being generated. We want to prevent infection. And it takes a little while to get all of us vaccinated. So if we all wear a mask, it helps everyone. The second reason is that we don't know how new variants might be resistant to the vaccine. So we want to protect ourselves against those variants. So the take-home messages here are that viruses take over your body to make more virus. You have the power to prevent the virus from becoming stronger by preventing infection. The vaccine is our strongest defense against this virus. It's our strongest weapon to destroy coronavirus. So you get to decide which side are you on. With the vaccine, you get to destroy coronavirus and save the people you love. Without the vaccine, the virus can use your body to hurt you and the people that you love. So I hope that you'll choose to join our side and destroy coronavirus by getting the vaccine. Good sources of information can be found on PubMed. It's a free service that is provided by the government. You can search different articles, and review articles are usually easier to understand. The Center of Disease Control is also a really good website for reading about vaccines and understanding how they work. And all of these are some of the articles that I read and referenced in this presentation. I want to give a special thank you to Dr. Jana Iwasa for sharing her animation with me that I shared with you. And thank you for your attention. I hope that this helped you to understand coronavirus and the COVID-19 vaccines. I'll have a survey in the comment section of this YouTube video. I would appreciate it if you would fill out the survey to help me understand what I'm communicating. Thanks so much.